All right, let's dive right in. We're going deep, deep into the heart of a colossal machine to follow an absolutely incredible hidden journey, the path fuel takes inside one of those massive ship engines.
I mean, really think about that for a second. How do you feed a 100,000 horsepower engine out in the middle of the ocean? This isn't like pulling into a gas station. We're talking about sustaining a mechanical titan, a floating city as it plows through the waves. It's this complex, super high-stakes ballet of engineering, and we're going to break it all down.
So, this entire epic journey, it really boils down to three crucial stages. You've got transfer, then treatment, and finally, injection. Think of this as our roadmap, following this fuel from a thick, raw sludge all the way to that explosive moment of power.
So our story starts deep, deep down in the hull of the ship, with the engine's absolute lifeline, the raw, unrefined fuel that it survives on. And let me tell you, this is nothing like the clean, clear gasoline you put in your car. Oh no, this is something else entirely.
So meet our main character, bunker fuel. It's this thick, heavy residual oil. You know, basically it's the stuff that's left over after the refining process is done, and it's just sitting there, stored at low temperatures in these enormous double-bottom tanks that actually make up the floor of the ship. This is square one. This is where the whole journey begins. Okay, so you've got this cold, thick sludge. How in the world do you even get it moving? Well, this first leg of the journey is all about waking the fuel up and getting it to its first stop for a bit of a cleanup.
And the whole process kicks off with the transfer pump. You can almost imagine this powerful pump waking up, starting to draw that cold, goopy fuel out of those deep storage tanks and pulling it up towards the first stage of its treatment. It's that first big step from hibernation to high energy.
So the fuel's first destination is something called the settling tank, and it's pretty much what it sounds like. It's like a giant holding tank. Its main job is to let all the heaviest gunk, we're talking water, salt, other impurities, just sink right to the bottom. But how does it do that?
Well, the secret is heat. The fuel gets warmed up to a pretty cozy 70 to 85 degrees Celsius, and that temperature range right there, that's the sweet spot to really get this whole separation process started. So, why all the heat? It's all about something called viscosity. See, heating up that thick bunker fuel completely transforms it. It goes from a tar-like substance to something that flows more like warm honey. And once it's like that, all that heavier sludge and water can just easily separate and settle right down to the bottom of the tank.
Okay, so the biggest, chunkiest impurities are gone. But now, the fuel has to face its toughest challenge yet, what I like to call the purification gauntlet. This is where the real deep cleaning happens, making sure only the purest fuel gets to move on. Right at the heart of this whole treatment process is the centrifuge purifier, and this machine is a total marvel. It takes that heated fuel and spins it at unbelievably high speeds. This creates this immense centrifugal force that literally slings the finer impurities and any remaining water outwards, separating them from the good stuff, the valuable fuel. Now, to make this super efficient separation happen, the fuel gets heated up even more. We're talking up to 95 degrees Celsius. The exact temperature can change a bit depending on the quality of the fuel you're starting with, but the goal is always the same. Get it perfectly clean.
So, having survived the centrifuge, the now clean, purified fuel gets sent to a holding area. It's called a service tank. You can think of it as a ready-to-use tank, just holding the fuel that's passed inspection and is all prepped for the final steps before it meets the engine.
And you know, ships have different needs, so there are usually two kinds of service tanks. The heavy fuel oil tank, that's for the purified bunker fuel, for the big main engine. But then you also have the diesel oil tank. That holds a lighter, cleaner fuel for things like the ship's electrical generators or for maneuvering around in port. The fuel is clean, yeah, but it's not quite ready for the engine yet. This next phase is all about final conditioning. It's kind of like a chef adding the final, precise touches to a dish right before it's served. Every single part has to be absolutely perfect. First up, it goes into the mixing tank. This thing is basically a final quality control checkpoint. It just swirls and blends the fuel to make sure the temperature and the consistency are perfectly uniform. No hot spots, no cold spots, just a perfectly consistent liquid that's ready for some serious pressure.
So from that mixing tank, a booster pump snatches the fuel and dramatically jacks up the pressure. This high-pressure fuel then gets pushed over to a viscosity controller, which fine-tunes its flow, getting it to the exact spec the engine needs for a perfect, powerful combustion. And right before it reaches the engine, the fuel has to pass one last security check, the hot filter. Now, this isn't just any old filter. It's heated, which is super important to stop any waxes in the heavy fuel from solidifying and clogging everything up. Its job is to catch any last, tiny, microscopic contaminants that could wreck the engine's incredibly precise parts.
All right, this is it, the moment of truth. After being transferred, heated, settled, purified, and filtered, the fuel is finally ready to meet its destiny inside the engine cylinder. This is where every single one of those steps pays off. The fuel injection pump now takes that already pressurized fuel and just cranks it up to a whole new level. We are talking about absolutely immense pressure here, and it's all needed for this final critical step. All that high-pressure fuel is then blasted through the fuel injector, and this thing basically acts like a super sophisticated spray nozzle. It atomizes the liquid fuel, turning it into an ultrafine mist. Think of an aerosol can, but literally thousands of times more powerful and more precise.
And that fine mist, that is the absolute key. It mixes perfectly with the super compressed air inside the cylinder and ignites in this massive controlled explosion. That is the moment of combustion. It's the release of energy that shoves the piston down and creates the colossal power needed to turn the propeller and move that whole ship.
But wait a second. What about the fuel that doesn't get used in that one single injection? I mean, this system is way too efficient to just waste it. There's actually one last little part of the journey we need to see, the return trip.
You see, not every single drop of fuel that's sent to the injector actually gets used. The excess, which is still under pressure and still hot, gets directed into a return line. This unused fuel travels all the way back to the mixing tank where it just rejoins the flow. It's this brilliant closed loop that makes sure nothing is wasted, and it also helps keep the temperature stable through the whole system.
So when you think about it, going from a cold, thick sludge in the bottom of a ship to a perfectly atomized, explosive mist, it's just an incredible journey. This entire invisible system of pumps and heaters and purifiers all working together just to create that one perfect moment of power over and over and over again. It really makes you wonder, right? What other complex hidden journeys are happening all around us every single day, just keeping our world in motion?